Right now, off the coast of Mexico, there's a monster spinning in the Pacific Ocean with winds strong enough to level a house. And it went from a harmless cluster of clouds to a full Category 5 hurricane in barely 3 days. But here's the part almost nobody's talking about. This storm is not a fluke, and it's not the real headline. It's a symptom. The ocean itself has changed, and what's happening beneath the surface of the Pacific right now is setting California up for a winter that could be one for the record books. Before I show you exactly what scientists are seeing, do me one quick favor. If you want to actually understand what's coming instead of just reacting to the next scary headline, hit subscribe, because on this channel we break down the real science, not the hype. Now let me explain why this ocean has forecasters genuinely on edge. Let's start with the storm itself, because it's the clearest warning sign of what's happening. Its name is Genevieve. On the 17th of July, it wasn't even a storm. It was just a low-pressure area, the kind of disturbance forecasters watch dozens of times a season, most of which fizzle out into nothing. But this one didn't fizzle. Over the following week, it slowly got its act together, and on the 24th of July, it officially became Tropical Storm Genevieve. That's when things got serious. Within about a day, it had already become a Category 1 hurricane. Then it kept climbing. By the 26th, it was a Category 3, a major hurricane. And by the early hours of the 27th, it had exploded into a Category 5, the most powerful rating on the scale, with sustained winds of 160 miles per hour and a central pressure that dropped to 925 millibars. That kind of leap from a tropical storm to a Category 5 in roughly 3 days has a specific name in meteorology. It's called rapid intensification, and it is one of the most dangerous and hardest to predict things a storm can do. To put Genevieve in context, it became the first Category 5 hurricane in the eastern Pacific since a storm called Christy back in 2024. These top-tier monsters don't come along every year. So the obvious question is, why now? Why did this particular storm blow up so fast and so violently? And the answer isn't in the sky. It's in the water, because the fuel that powers every hurricane on Earth is warm ocean water, and right now the Pacific is running a fever. Here's how it works, in plain terms. A hurricane is basically a giant engine that runs on heat. It pulls warm, moist air up from the ocean surface. That air rises and cools. The moisture condenses into towering clouds and rain, and that process releases enormous amounts of energy that drives the winds faster and faster. The warmer the water, the more fuel the engine has. Forecasters generally say you need sea surface temperatures of at least around 26 degrees Celsius, which is about 79 degrees Fahrenheit, just to get a hurricane going. But temperature at the very surface is only half the story. What really lets a storm rapidly intensify is deep, warm water. If the warmth only goes down a few feet, a strong storm churns up cooler water from below and basically chokes itself out. But if that warm layer runs deep, the storm has an almost unlimited buffet, and it can keep strengthening explosively. And right now, across the eastern Pacific, the water is not just warm at the top, it's warm well below the surface too. Recent measurements have sea surface temperatures across much of the region running about 2 to 3 degrees Celsius above normal. That might not sound like a lot. 2 or 3 degrees, who would even notice that in a swimming pool? But for a hurricane, that difference is the equivalent of pouring gasoline on a fire. It dramatically raises the ceiling on how strong a storm can get and how fast it can get there. And this is where the bigger story comes in, because that abnormal warmth isn't random. It has a name, and it's a name you've probably heard before without fully understanding what it means. It's called El Niño. So what exactly is El Niño? Strip away the jargon, and it's this. Normally, trade winds blow across the tropical Pacific from east to west, pushing warm surface water toward Asia and Australia, and allowing cooler water to well up along the coast of South America. During an El Niño, those trade winds weaken or even reverse. When that happens, all that warm water sloshes back eastward and piles up across the central and eastern Pacific, right off the coast of the Americas. It's one of the single most powerful climate patterns on the entire planet. And when it shows up, it doesn't just change the temperature of one patch of ocean. It rewires weather across the whole globe, shifting where storms form, where rain falls, and where droughts take hold thousands of miles away. And here's the crucial part for our story. This is not a normal El Niño. As of mid-July 2026, the key measurement forecasters watch, an index tracking ocean temperatures in a specific stretch of the tropical Pacific had climbed to plus 2.1 degrees Celsius. To give you a sense of scale, anything above about plus 1.5 is already considered a strong event. Plus 2 is the territory of a very strong El Niño, the kind people sometimes call a super El Niño. And it's not done. NOAA's Climate Prediction Center put the odds at 81% that this becomes a very strong event by late 2026, and a 97% chance it persists into early 2027. In fact, forecasters have gone on record saying this may end up being one of the strongest such events ever recorded. So when I say the Pacific is running a fever, I mean it's spiking, and the doctors watching the charts are getting concerned. Now, this is exactly the point where a lot of channels go off the rails, so let me be very clear and very honest with you, because you deserve the real science. You may have seen videos claiming that solar flares are what created and strengthened this hurricane, or that the storm's lightning is triggering earthquakes, or that a planetary alignment is loading up California's fault lines. I want to address that head on because it matters. None of those claims hold up. Solar flares do not create or strengthen hurricanes. Hurricanes are driven by ocean heat and atmospheric conditions, full stop. There is no credible mechanism by which the sun's flares reach down and spin up a tropical cyclone. Hurricanes don't trigger earthquakes through electricity, and planetary alignments don't cause earthquakes either. The gravitational pull of distant planets on Earth's crust is vanishingly tiny, far too small to matter. These ideas sound exciting, and I understand the appeal, but they take real, verifiable events and wrap them in a story that simply isn't true. The actual science is dramatic enough on its own, and it has the advantage of being real. So let's stick with what the data actually shows. And what the data shows is a genuine, well-documented connection between El Niño and dangerous hurricanes in this part of the world, one that scientists have studied for decades. This is the real link, and it's fascinating. During an El Niño, the eastern Pacific becomes a far friendlier place for hurricanes. The warm water gives them fuel, and just as importantly, El Niño tends to reduce something called wind shear in this region. Wind shear is when winds at different heights in the atmosphere blow at different speeds or directions. It's basically a hurricane killer. Strong shear rips a developing storm apart before it can organize. When El Niño calms that shear down over the eastern Pacific, storms are free to grow tall, symmetrical, and powerful. A peer-reviewed study published in 2025 found that El Niño significantly increases the odds of rapid intensification in the eastern North Pacific. Read that again. Not just more storms that blow up fast, exactly like Genevieve just did. This is precisely why NOAA, back in May, forecast an above-normal eastern Pacific hurricane season for 2026, predicting somewhere between 15 and 22 named storms. Their reasoning pointed directly at the developing El Niño, and the season has more than delivered on that promise. It started with an absolute bang, 3 named storms forming by early June, the busiest opening to a season in this basin since 1985. And now we've got our first Category 5. The pattern the scientists predicted months ago is playing out in real time, right in front of us. That's what real forecasting looks like, and it's a lot more impressive than blaming the sun. But here's where I need to shift your attention, because so far we've been talking about a storm out over open water. Genevieve, for all its fury, is not expected to make a catastrophic landfall. It generated dangerous surf and rip currents along the coast of Baja California and southwestern Mexico, and it battered a group of remote islands with big waves, but it's tracking out to sea and weakening over cooler water. So if the storm isn't the direct threat to California, why did I open by telling you California should be worried? Because the same ocean warmth that built Genevieve is about to point its consequences straight at the west coast, just not in the form of a hurricane. To understand that, we have to follow the warm water and the weather patterns all the way to winter. Here's the connection. That massive pool of warm water in the tropical Pacific doesn't just power hurricanes in summer. It fundamentally changes the atmosphere's circulation heading into fall and winter. Specifically, El Niño tends to energize and shift the jet stream, the fast river of air high in the atmosphere that steers storms across the continent. During a strong El Niño, that storm track tends to dip southward and aim a parade of wet Pacific storms right at the southern half of the United States, and that includes Southern California. For a state that has spent years worried about drought, that might sound like great news, but there's a catch, and it's a serious one. When you dump an enormous amount of rain onto California's landscape in a short period, especially onto hillsides scarred by recent wildfires, you don't get a gentle drink of water, you get floods, mudslides, debris flows, and coastal erosion. History backs this up in a big way, and this is the part that should get your attention. El Niño is behind some of the most destructive winters California has ever recorded. During 3 of the 4 very strong El Niño events in the modern global record, downtown Los Angeles received significantly more rain than usual. In 2 of those years, 1982 to 1983 and 1997 to 1998, downtown LA got more than double its normal yearly rainfall. Let that sink in. 2 years of rain crammed into one. The very strong El Niño of 2015 to 2016 brought record coastal erosion, chewing away at beaches all along the California coast. And even the more recent strong El Niño of 2023 to 2024 delivered well above average rainfall to coastal Southern California. So when forecasters look at the ocean today and see an event that may rival the biggest on record, and then they look back at what those past events did to California, you can understand why the word they keep using is not excitement, it's caution. Now, I want to be careful and precise here, because honesty is the whole point of this channel. A very strong El Niño makes a wet, stormy winter more likely for California. It does not guarantee it. Weather is not a machine where you push a button and get a fixed result. There have been El Niño years that didn't deliver the expected deluge, and there are always other factors in play. Scientists talk in terms of probabilities and increased risk, not certainties, and so should we. What we can say with real confidence is this. The ocean is loaded with abnormal heat. The pattern that historically brings California its most dangerous winters is firmly in place and strengthening, and the risk of a wet, flood-prone, landslide-prone winter is meaningfully elevated compared to a normal year. That's not fear-mongering. That's just reading the gauges, honestly. And the effects go far beyond rain, which is something most people never hear about. This warm ocean is already reshaping life along the California coast in ways that are honestly a little surreal. As the water heats up, warm water species start showing up in places they normally never would. Marine biologists are talking about an increased likelihood of shark sightings off Southern California, and in the rarest cases, past strong El Niños have even drawn whale sharks toward Catalina Island. Marine mammals and fish shift their positions too, following their food as it moves. But it's not all wonder and novelty. There's a darker side beneath the surface. Warm water during past strong El Niños has been linked to drops in plankton, which is the foundation of the entire ocean food web, and to a higher chance of harmful algal blooms, the kind that can poison marine life and shut down fisheries. Scientists have watched California sea lions struggle in these conditions, with pups often born smaller and weaker because their mothers can't find enough food. So this warm ocean is a double-edged sword. It brings some spectacular sights, and it quietly starves parts of the ecosystem at the same time. There's also a compounding problem that makes this year particularly concerning, and it's worth understanding. This El Niño isn't arriving to a calm, normal ocean. Off the coast of Southern California, there was already a marine heat wave in progress for reasons unrelated to El Niño. So now you've got El Niño's warmth stacking on top of warmth that was already there, prolonging and intensifying the whole situation. And layered on top of all of it is the long-term background warming of the oceans from human-caused climate change, which raises the baseline temperature that everything else builds on. Think of it like a stack of loaded dice. Each factor on its own tilts the odds toward extremes, and this year, several of them are stacked together. That's why forecasters are treating this event with the seriousness they are. Let me bring this back to the storm for a moment, because Genevieve isn't alone out there, and that tells you something too. Just before it formed, another system, Hurricane Fausto, had already become the season's first hurricane. Fausto climbed to a Category 2 before drier air and cooler waters knocked it back down, and it eventually drifted toward Hawaii as a weakening system. Earlier in the month, a storm called Elida spun up, sent a burst of high surf toward Southern California, and even contributed to conditions that worsened wildfires in Oregon through its lightning. One storm after another, forming in quick succession, all feeding off that same overheated ocean. When you see a basin producing hurricanes this readily, this early, and this intensely, it's not a series of coincidences. It's the fingerprint of an ocean primed for exactly this. The individual storms are the sparks. El Niño is the reason the whole region is soaked in fuel. So what should you actually watch for in the weeks and months ahead? First, keep an eye on that ocean temperature index. This is the practical part, and it's more useful than any doomsday prediction. If it keeps climbing, or holds steady at that very strong level heading into fall, the case for an active, impactful winter in California gets stronger. Second, watch the Eastern Pacific for more rapid intensification events like Genevieve's through the rest of the hurricane season, which runs until the end of November. Each one is another data point confirming just how charged this ocean is. And third, as we move from fall into winter, watch the jet stream in the storm track. If it sets up in that classic El Niño position, dipping south and aiming at California, that's your signal that the wet season could arrive with force. The real story isn't going to be one dramatic event. It's going to be a pattern that unfolds over months, and now you know how to read it as it happens. I also want to leave you with the most important takeaway, the one that separates understanding from panic. A strong El Niño is not a prophecy of doom. It's a shift in the odds. It's the difference between playing a game with fair dice and playing with dice that have been weighted toward extremes. Most winters, California muddles through. But in a very strong El Niño year, the chance of hitting one of those destructive, memorable, record-breaking winters goes up substantially. Preparation matters. Communities in fire-scarred areas, people living below hillsides, anyone near the coast, these are the folks who benefit most from paying attention now, while the ocean is still just quietly warming and the storms are still out at sea. The time to understand a risk is before it arrives, not during the flood. And that's really the heart of why I made this video. It would be easy, and honestly, it would probably get more clicks, to tell you the sun is firing beams that spawn hurricanes, or that the planets are lining up to crack California in half. But those stories don't help you. They just scare you and leave you knowing less than when you started. The truth is more interesting anyway. We have a real, measurable, scientifically documented chain of events unfolding in front of us. A trade wind pattern weakens. Warm water floods eastward across the Pacific. That warmth supercharges hurricanes like Genevieve into rapid intensification. And that same warmth, carried into winter, tilts the odds toward a stormy, dangerous season for California. Every link in that chain is backed by data and by decades of research. No mysticism required, just the planet's own machinery, running hot. Let me tie the whole picture together one last time, so it's crystal clear in your mind. The eastern Pacific is running 2 to 3 degrees above normal, with deep, warm water beneath the surface. That's the fuel. A very strong El Niño, sitting at plus 2.1 degrees and climbing, with an 81% chance of becoming one of the strongest on record, is the engine driving that warmth into place. Hurricane Genevieve, exploding from a nothing disturbance into a Category 5 in about 3 days, is the proof of concept, showing exactly what that overheated ocean can do. NOAA predicted this active season months in advance based on El Niño, and the season delivered with its busiest start since 1985. And the same conditions that built these storms are lining up to steer a wet, potentially destructive winter toward California, following a historical script written by the great El Niño winters of the past. Every piece of that is real. Every piece is verifiable, and every piece points to the same conclusion. Something significant is happening in the Pacific, and it's not finished. The ocean has always been the master switch for so much of our weather, and right now that switch has been flipped hard. Over the coming months, we're going to watch this story unfold together, from the last hurricanes of the season to the first big storms of the California winter. Some of it will play out exactly as the models predict. Some of it, as always with weather, will surprise even the experts. That's what makes this fascinating rather than just frightening. We get to watch one of the most powerful forces on our planet do its thing. And thanks to real science, we get to understand it as it happens instead of being blindsided by it. So here's where I'll leave you. If this actually helped you understand what's going on, instead of just adding to the noise, that's exactly what I'm going for on this channel. And the best way to support that is simple. Give this video a like because it genuinely helps more people find real answers instead of recycled myths. Drop a comment and tell me what you're seeing where you live, whether it's strange warm ocean water, early storms, or unusual weather, because I read those and they often shape what I cover next. And most importantly, subscribe and turn on notifications, because when this El Niño makes its next move, whether it's another explosive hurricane or the first atmospheric river slamming into California, I'll be right here breaking it down for you clearly, calmly, and honestly. This is W for weather, where we follow the real science of our restless planet. The ocean has made its move. Now we wait to see what it does next. I'll see you in the next one.